Put the agenda slide on, please, Nick. Thank you. So it's going to be a fairly tight event. So we've got 2 hours. We have a series of short presentations. I'm really happy to welcome Chris Small from the BEIS Heat Network Delivery Unit at BEIS to give us a bit of context on what they're doing. And also from 2 of our THERMOS partner organisations, Islington Council and Fortum, which operates quite a large district heating system in Jelgava in Latvia. And they'll be showing us how they've been using THERMOS. There'll be a brief chance to ask questions after Chris's presentation, which follows this introduction, and then a bit more time for Q&A about THERMOS in the last slot, which is at about 11:25, hopefully, if we run to time. So first of all, what I'll do is give you a little bit of background about CSE in case some of you aren't familiar with us. So we've been around since 1979, I think formed as part of the reaction to the first oil crisis, or might have been the second oil crisis. We are a charity based in the UK working on fuel poverty and climate change. Our main areas of activity are providing advice to households and managing retrofit schemes, supporting the development of local community energy projects and processes, and research and analysis informing policy and supporting decision making, and that latter part is the area that I manage. We have about 80 staff and we usually have around 80 projects on the go. And we're an independent charity and non-profit business funded by our clients on a project-by-project basis, so kind of like a consultancy, but in a non-profit kind of context. Okay, Nick, do you want to advance? So we've been kind of working on the problem of trying to figure out how to decarbonize heat at a local level for quite a long time. The images on this slide sort of clockwise. Well, actually not clockwise, how would it be? So the top row, the top left image is the London heat map, which we built in 2009, which was, I think, one of the first free online heat demand maps. That was for Greater London Authority in 2009. The next one across top right was a Southwest heat map, which we built in 2010. And that was the first time we sort of started modelling this heat demand at the level of individual buildings and addresses. In 2012, bottom left image, we built the national heat map for BEIS, which covered England, and started to sort of introduce slightly more sort of analytical tools into the web applications. And in 2019, we updated the London heat map. So the bottom right square is a screen grab from the current London heat map, which was published last year. So all these tools were designed to be free at the point of access and ensure widespread use to help local authorities and industry understanding heat supply and demand options at a local level. And essentially what happened was with each new project, we kind of evolved our methods and the sophistication got better as we learned, and more data became available and more computing resources became available. So next slide, please. So the London heat map was the second version of the London heat map. It's the first one that actually had any kind of modeling tools built into it, but it still didn't address what for us was always the sort of big question, the thing we were trying to get to, which was what network should I build, which is an optimization problem, because in any area there's a very large number of possible things you can do, and it's quite hard to work out what the best one is, whatever your definition of best is. And that's what the THERMOS project has been about. It's the latest development, and it builds not only on all of our previous work, but also the work of a large number of other academic and non-academic European partners. Before we get into the detail of THERMOS, I would like to introduce Chris Small, who's head of Project South in the BEIS Heat Network Delivery Unit. And I think that's part of the wider Clean Heat Directorate. Chris is going to give us some policy context and update us on the latest developments with the team, including, I think, some work they're doing on heat zoning policy development as a potential way forward, and that's a piece of work that we're also involved in. So I'll now hand over to Chris.
Thanks, Josh. Good morning, everyone. Yeah, I'm Chris Small from the Heat Network Delivery Unit in BEIS, and I head up our project delivery team for the south of the UK. Josh has invited me to spend about 10 minutes talking through some government support for heat networks in the UK. So I've got a few kind of high-level slides, but I'm happy to take any more detailed or specific questions at the end. I apologise for video as well. It's blocked on Zoom for me, so you'll have to deal with audio for now. Next slide, please. Okay, so first of all, most of you will likely be familiar with the diagram on the right, which shows the emissions from heating in the UK. So about a third of all emissions are from heat, and about a fifth of those are from buildings, so domestic and non-domestic buildings in the UK. And we will need to decarbonise heat in all buildings by 2050 if we are to reach our net zero targets. To decarbonise heat, the government has set out different pathways, different options, which will work in different forms locally, including electrification, hydrogen, other forms of green gas, and heat networks. And working out how to deploy these locally, as I'm sure most of you on the call will be familiar, is very complex. In terms of heat networks, why heat networks? The government's committed to heat networks being built in critically the right place. So we see heat networks as a kind of no regrets option, which can save carbon both now and in the long run. They have the ability to keep customer bills low, again, so long as we construct them in the right place. They offer huge opportunities to be flexible and resilient, which will in turn have a potentially positive impact on other energy vectors, such as power and transport, so the interplay between heat, power and transport. And they can also be cost effective, so obviously offering growth and regeneration opportunities in towns and cities across the UK. Currently, we're just over 2% of heat supplied in the UK is from heat networks, and much lower than some other European countries. But modelling from both us, the CCC, and others suggests that we could get up to about 18% by 2050. Next slide, please. Okay, so government has been providing different types of support into the market over the last few years, and this has included the introduction of standards such as Heat Trust and CP1, the Code of Practice. We funded feasibility funding and general kind of market guidance via the Heat Network Delivery Unit, or HNDU, which is our delivery focused team. We've provided we will have provided around £600 million of grants and loans via the Heat Network Investment Project and the upcoming Green Heat Network Fund from 22 to 25. We funded innovation, so work on different metering, HIUs, data, etc. We've also been trying to build the supply chain in the UK, so building capacity, bringing in partners from across Europe and across the world, and also bringing in kind of expertise from decreasing UK energy markets. And the last thing as well is policy, so a lot of work under the policy banner, but as part of that, we're trying to establish a sustainable market framework in the 2020s, introducing future regulation of the sector, and also introduction of the heat metering and billing regs. And most recently, we've announced that we'll be consulting on a heat network zoning policy in spring 2021, which is probably most relevant to this call today. Next slide, please. Okay, so most of our development support, and by development support, I kind of mean early stage feasibility studies, has been focused on funding individual studies. So we funded probably about 300 to 400 different studies across large swathes of the UK. And typically we funded these in 4 different stages. So the first is mapping and master planning. So essentially the identification of opportunities within a locale, so within a town or city. The next is feasibility, so a detailed assessment, usually of the most economically viable option within a town or city, and that usually comprises around 10 to 50 buildings, some smaller, some larger. The next stage is detailed project development, so working out commercially and financially how you might deliver that kind of core scheme in future phases. And then commercialization, so the procurement of that scheme, funding, signing contracts, etc. And then hopefully it will lead on to construction. This has led to significant growth in an interest across the whole of the UK, and also has led to a lot of ambition within particularly local authorities, but also a range of other local stakeholders in stimulating discussion around heat networks. However, there still needs to be a kind of significant increase in the scale of these projects to meet the ambition, both of central government and local government. And it's this scale which kind of brings tools and algorithms such as THERMOS and others into play. In terms of the role for those tools and those algorithms, so I guess typical kind of feasibility studies are usually restricted to a kind of deliverable subset of buildings that are likely to connect. So in the region of about 10 up to about 200 is the most we've had. And that's largely due to kind of the manual modelling of those individual buildings, being able to go into them, understand them, and model them through existing software. The potential role for THERMOS and others is, however, kind of changing some of that. So there's a potential to obviously model the whole of the town or a whole of a city. So rather than looking at between 10 and 200 buildings, looking at a much larger kind of section of a town or city. It can make decisions between different approaches at a local level, if given the right kind of assumptions and parameters. And also it tends to be easier to run kind of several iterations of modeling. So for example, what happens if you change a couple of the input assumptions and parameters? To test this out, we've recently kicked off a heat network zoning pilot in 6 cities. So these are shown. We've got Bristol, Birmingham, Nottingham, Manchester, Leeds, and Newcastle. And that piece of work's emanated from a much larger project, which looks at how you would decarbonise heat within a city. So not just looking at building heat networks, but how you decarbonise heat in a city. And critically, it was important to determine where heat networks obviously should be constructed within a city, but also critically important to work out where you should deliver kind of building level solutions to enable people to be able to kind of proceed without the fear of being locked into the wrong solution. So that's the main reason why we've kicked off the heat network zoning pilot within these 6 cities. Next slide, please. And as part of this city work, as Josh said, we're working with CSE to pilot a methodology or an approach to determining where you might draw heat network zones within a city. And whilst this emanates from that project, it will obviously link into the zoning consultation, which we've also announced. So the two aren't directly linked, but essentially this pilot will feed in and provide useful evidence and intelligence to that consultation in spring 2021. So what are we doing in terms of the pilot and how are we using THERMOS? So as I said, we've agreed a kind of pilot approach back in August this year, but that will likely need refining, and there's things that we're kind of finding out as we go. But yeah, we're using a pilot approach for now. We're directly working with local city consultants who have already been engaged with each of these cities probably for the last 18 to 24 months, and also kind of local intelligent stakeholders to input relevant data at the outset. The model itself will kind of be created for each of the cities, and that will underpin citywide decision making. So an initial model will be built this side of Christmas, and then after Christmas, the kind of consultants working with each of the local authorities will be able to adapt, play around, and change some of the kind of assumptions to enable that citywide decision making. The main purposes of this is to identify areas of the city where you might say that heat networks are low or no regret zones, and also critically where they're not. The calculation which underpins a lot of that work is essentially working out where you would build a network solution within a city versus a building level solution. So as you'll probably expect, there's a lot of kind of calculations and work that sits behind that, but essentially it's working out network versus building level. And then in the background, there's kind of, we see it as different layers. So essentially you have a kind of demand layer, so your heat demand. Critically, you have a heat supply layer as well, which maps on the different low carbon sources within a city. Then you've got your distribution layer, so the kind of algorithm that THERMOS goes down, looking at each of the different routes within the city. And then you have the economics to work out, you know, is a network solution better than a building solution, or is a building solution better than a network solution? In terms of the analysis, there's two main types of analysis that we're doing as part of the pilot. So the first is what we're calling, for want of a better term, heat network friendly connections. So those are the types of buildings that we typically see connecting to heat networks. So public sector anchor loads, large private sector loads, campuses, so whether that be hospitals, universities, social housing, and large scale new development. So that will form one part of the analysis. And then we'll also be modelling all buildings within a city. So taking account of, you know, smaller loads, individual domestic properties, etc., etc. So there'll be two types of analyses, and we'll be able to compare and contrast between the two approaches. In terms of the output, so as Josh said, we're working closely with Josh and each of the 6 cities at the moment on kind of building those models, and we hope to have some outputs from that piece of work in the spring or summer 2021, and that will directly feed into our consultation that we'll hopefully release at the same time. I think that's it from me. Thank you for listening. I'm happy to take any questions on any of that.
Hi Chris, it's Jess from CSE. I'll manage the chat. I'll try and manage the Q&A so you can focus on answering the questions. So if anyone wants to ask a question, either turn on your video so that I know I can see that you want to ask a question and I'll call on you to unmute, or just put it in the chat bar. So Chris, the first question was from Peter, who said, do you know what the significant, actually Peter's just come on, so maybe he can ask his question himself. Do you want to unmute, Peter?
Morning, Chris. Thank you. Yes, I noticed, and you mentioned it, that the heat networks improvement or implementation funding is going to be transferring over to the green networks heating. I just wondered what the main difference between the two is. There a specific difference in the thrust and in terms of bridging the commercial gap?
Yeah, sure. Thanks, Peter. Yeah, so the Heat Networks Investment Project, HNIP, is the capital funding at the moment, and that runs till March 2022. And then the idea being that the Green Heat Network Fund will kind of follow on transition, hopefully from about April to June 2022. So there should be, we're trying to ensure that there's a seamless transition between the two. I guess for me, the main difference is the Heat Network Investment Project, when it was launched back in 2018, and we had a pilot back in 2017, we were still funding gas CHP type heat networks, and we were providing both grants and loans into gas CHP projects. The way that the kind of competitive scoring works for HNIP, we've now seen that most of those projects aren't faring as well against a much larger number of either heat pump based projects, energy from waste, or some as well using industrial heat recovery. In terms of the Green Heat Network Fund, so as you'd expect from the title, we will only be funding green heat network supplies. So essentially that will look at kind of decarbonising some of our existing legacy projects in the UK, but also constructing new ones. But the key difference for me is that the Green Heat Network Fund will only fund networks which have a green heat supply. There is a consultation was launched last Monday and it goes into what we mean by green. So it's kind of pegged to a carbon intensity. But yeah, I'd direct you to the documentation rather than getting into details now. I'm happy to, but yeah, there's quite a lot to it.
Great. And Erica asks, with network versus building level, do you mean standalone equipment? Is an estimation based on building energy demand only, or also CapEx, OpEx?
Yeah, hi Erica. So yeah, so again, this is emanated from a kind of a shift in the way that we've looked at things. So I guess all the kind of net zero declarations, a lot of heat network studies were based on comparing heat networks versus gas, whereas now the question that seems to get asked a lot is what's the lowest cost, lowest carbon way to achieve heat decarbonisation, which is slightly different. So yes, it does look at standalone building level solutions. And at the moment, I think the pilot approach is largely using individual air source heat pumps, and it builds in some assumptions around coefficient of performance, grid upgrades, electricity costs, CapEx, OpEx, and RepEx, and then basically compares that to the heat network solution.
Great. The next one is from Andy, who says, is the modelling also looking at heat generation and availability of primary energy sources and gas and power grid constraints?
Hi, Andy. Yes, in short. So BEIS is doing a separate piece of concurrent work, which is looking at mapping all of the low carbon heat sources in the UK. So at the moment, I think we're up to about 15,000 different potential heat sources. There are some kind of complications with data and data sharing, but the intention is that we'll use at least a subset of those as part of this pilot approach, and that actually informs, the cost of that, I say generating the heat, the cost of recovering that heat, if you like, or the cost of generating it if it's a new heat supply, will directly feed into the kind of THERMOS approach. In terms of gas and power, again, a lot of the power considerations require a kind of granularity of data, which some of it is available, some of it isn't available at the moment. So we're having to make some assumptions in the pilot. However, we are working with other colleagues in BEIS, the DNOs and the Electricity Network Association to try and secure more granular data to enable us to do that, to do kind of better modelling at a very local level.
Great, thank you. And Vicky's questions has already been answered by Josh in the chat. So moving on to Charlie says, hi Chris, why is the HNDU not available to parish and town councils?
Good question. So HNDU is not available to parish and town council simply because our mechanism of transferring funding from central government to local stakeholders is via a Section 31 grant, and Section 31 grant has a long list of eligible local authorities, if you like, and unfortunately town and parish councils aren't on that list. However, there are ways around that. So if there are any that are listening that want to secure funding from us, we can discuss ways around that.
Great, thank you. And Graham asks, are you able to say whether there will be a round 11 of the HNDU?
Hi, Graham. Not at the moment, simply because we get a yearly funding settlement from government, and we never get that announced until usually about April. Hence, we have a gap. For those familiar with the HNDU process, we have a gap usually between December and April each year. However, yeah, we would expect that we would be likely to get funding again next year, because the funding for our kind of feasibility projects feed the pipeline for both HNIP and the Green Heat Network Fund. So without that funding, it's difficult to see where the pipeline would be coming from. So I can't commit to it, but at the same time, yeah, we're hopeful that we will get funding next year.
Thank you. And this will probably be the last question, and then we'll have to move on to Martin. So Kate asks, will there be the same minimum heat demand for the GHNF? If so, can smaller projects be aggregated? For example, a few small off-gas grid villages bidding together.
Yeah, hi Kate. So the consultation that was out last Monday includes for the same 2 GWh minimum threshold. However, there is a direct consultation question in there about that 2 GWh threshold. So we've already discussed with a range of stakeholders as to whether that should or should not be in there. And there is, I believe, some discussion around whether you start aggregating projects and whether that should be allowed or not allowed. And that's in relation to both off-gas grids and also this came up in relation to kind of shared ground loop systems as well. So yeah, so it's in the consultation, and yeah, we'd welcome responses on that.
Great, thank you very much. It's now past, so I think it's now time for Martin's section on introducing THERMOS.
Thanks, Jess.
Great. Yeah, thanks, Jess. So yeah, hi everyone. I'm Martin Holly, work with Josh at CSE, and these are just a few brief slides just to provide a bit of context to the THERMOS project before we actually have the demo of the tool itself from Josh. So if we move on to the first slide. So why did we think we needed something like THERMOS anyway in the first place? Well, as Josh kind of already touched on, we recognise the importance of heat networks in helping to deliver the benefits of emission reduction targets, energy affordability and security. And the fact that more effective tools were needed to accelerate their deployment. But we also knew that planning these networks takes quite a long time and is, we all know, it's costly and typically involves different methodologies depending on who's doing them, which tends to lead to a lack of consistency across studies. So it's difficult to make kind of meta comparisons, which you know, can often be useful. And we knew that the vast majority of local authorities struggle with having enough internal resource as well to engage in heat network planning or to build any capacity to do so. So these were the key problems we were trying to address in coming up with THERMOS. Next slide, please. Thank you. Yeah, so what we've ended up with is the THERMOS tool, and that stands for Thermal Energy Resource Modelling and Optimization System. I guess the main thing to say up front is that it's open source and web-based. It has two main functionalities around energy demand estimation and mapping, and the optimization of networks and energy supply plan. And a key benefit is that it allows surprisingly fast pre-feasibility analysis. So it's well suited to the mapping and master planning phase of network development, but also we think for some elements of the project feasibility phase too. And if we move on to the next one, here I just wanted to tell you a little bit about the team behind THERMOS. So we were lucky enough to get funded by the EU's Horizon 2020 programme. And there's 15 partners in the consortium spread across 8 countries, and they're the green ones that you can see on the map there. And the UK partners were Centre for Sustainable Energy, and from London we had Islington Council, the GLA and Imperial College. And also in total we have 8 municipalities represented in the consortium, and they're made up of 4 pilot authorities who we work closely with in developing and embedding the tool. And these are Warsaw, Islington, Granollers in Spain and Jelgava in Latvia. And alongside those 4 replication authorities, and they were the GLA in London, Cascais in Portugal, Albula in Romania and Berlin, who then benefited from the experience of the pilot authorities in deploying THERMOS. The rest of the team is made up of kind of technical input from Aalborg University in Denmark and Criara Consultants in Spain, and support from energy agencies, Dana in Germany, Leaf in Latvia, and CAPE in Poland. And we also have Italy Europe, so that's local governments for sustainability, helping us out on the comms and dissemination side. And they're particularly well connected with local authorities across Europe, so that's been very helpful. Also, just to say quickly that colleagues from 2 of the pilot authorities, that's Islington and Jelgava, will be sharing their experiences of using THERMOS a bit later on in the session on case studies. So if we move on to the next slide, we'll look at the project timeline. So we kicked off the project way back in 2016, seems so long ago now, and somewhat unusually, but fortunately, we managed to get 2 extensions on the original 3-year project. So there's now only 4 months left until we finish in March next year. But along the way, apart from the technical modelling and software development work, we also rolled out a series of train-the-trainer certification programs and established a city interest and ambassador group to help disseminate the project and, of course, the tool. So we have quite a wide group of stakeholders by now who are disseminating the tool, and we know that they're trying their best to make it widespread. And so the final phase is really focusing on model validation work, user testing, and a few improvements to the user interface. But we've this last phase, we've also been thinking ahead and doing a bit of business planning to decide on how to offer, maintain, and develop THERMOS beyond the end of the project. This is still a work in progress, but safe to say there'll be a free access version as there is now for some time yet, and there'll be options for like a premium version with enhanced features. So just watch this space with regard to that. So yeah, I wanted to really keep that brief. So just to give you a flavour of the project and the context of the THERMOS tool, but I think I'll stop there and hand over to Josh for the live demo now. But just to say, we'll be showing a link to the tool at the end of the presentations if you fancy a go yourself at some point. So that's all from me. Thanks very much. And over to Josh.
Thanks, Martin. Nick, do you want to? Oh yeah, okay, you're ahead of me. Thanks. I'll now attempt to share my screen and hope that none of the many things that could go wrong do go wrong. Okay, so could somebody confirm that you can see my browser window now, and only my browser window?
Yeah.
Great. Okay, so I've only got about 15 or 20 minutes, and it's quite a complicated piece of software, so it's going to be a bit of a whistle-stop tour. Apologies for that, and there will be a chance for answering questions at the end. And also, you can just go and try it, and there's quite a lot of documentation under the help pages. So if you've got a very detailed question, it might well be that the best thing to do is have a look there. So now I'll start trying to show you around it. The first thing to note is it's a web app. So I'm logging into a web app, which is at tool.thermosproject.eu. I've got a bunch of different projects that I've been working on using the tool. I'm going to click on the project that I prepared for the purposes of a demonstration. And the first thing to say is that the first thing you need if you want to use THERMOS is a map of the locations of the buildings and their heat demands and of the roads, etc. So there's 2 ways of generating that map. One is if you have that data that you've produced yourself, you can simply upload it. If you don't, you can generate it using the tool. So I'll show you how you do that, but I won't wait for it to complete because it can take a while. I've got a couple of, here's one I made earlier, kind of Blue Peter type setups waiting. So if you click on map, give it a name, what we've done is integrate THERMOS with OpenStreetMaps. So what you can actually do is browse the OpenStreetMaps map, as it were. And essentially, you can define the area that you are interested in studying as a box. and then you can request the OpenStreetMap roads data as well. You tell it what you think the heating degree days per year are for the area, because that's used in weather correcting the demand estimates, and you press create map. And essentially what happens is THERMOS now talks to the OpenStreetMaps interface, grabs the data and builds a map, rather than wait for that to complete, because that's could take a little while and isn't very interesting to watch happen. I'll just jump into a map that I made earlier of the same area, roughly the same area. So what I've done here is, and perhaps I'll put a satellite base on. So this is a little part of Islington, Bloomsbury in London. You can have a couple of different base maps. It's easier to understand what's going on without a map, so I'm going to leave that off. And what we have here is a bunch of buildings and road segments, which would be the components of a network. And what we're wondering is, what network should I build in here? And if I were to select all the objects in the map, I would see that there is 815 buildings in this selection. So that's a surprisingly big question because of the number of different permutations you can get out of a set of 800 things, not even counting the roads. So that's the point of THERMOS, to make that easier. The first thing you have to do is say that you have a heat supply. So you click on an individual site where you are saying you can install a supply, and you characterize that by saying how much heat's available at what cost. I'm just putting silly numbers in here because I'm not going to run this, and I've got another one I made earlier to show you the result. But essentially, you've said that you have heat at this location on the map. The next thing you do is tell the software what buildings you want to be included in your question, so to speak. So you might just sort of draw a box around there and say, I want to see if I can make a network out of these buildings. And now I can sort of toggle the status of that selection. And what I'm going to say is, so white means that they're not allowed in the answer, and blue means it's up to the computer, and red means they must be in the answer, or the answer is illegal. So I'm going to set them all to optional here. I'm going to do another little thing, which is draw a slightly bigger box around the first box, restrict that to the roads only, and then set those roads also to optional, because you get these edge effects where if a building's at the edge, you can't be sure it'll actually be connectable because of the way the roads go. So that's the only reason I've done that. You then have to tell THERMOS some information. So every building already has on it an estimate of the heat demand and the peak heat demand, which is predicted based on the size and shape of the building using some models that we developed as part of the project. So let's see how much detail to go into here. You also have sort of category information about the buildings. Here we've got UCL's Institute of Education by random chance. Apologies to the colleagues from Imperial College that are on the call. I noticed. Hello, Marco and Kamal. But yeah, this is the information that comes out of the OpenStreetMaps database. If you were making your own map data, then you would be in control of what attributes would appear there. So the other things you have to tell it are some stuff about what it's trying to optimize. So you can either say, make me the best MPV network, or you can say, make sure all the heat demands of these buildings are met in the least cost way. And you can also offer insulation measures, and you can also offer alternative heating systems. So the model run that I'm doing, which is probably most similar to the work that Chris Small was describing, is basically saying for each building, should I network it, or should I give it its own heat pump? And in parallel, should I install solid wall insulation on it if that's applicable to that building? And then the optimizer basically in whole system mode is saying, there's going to be a cost, obviously, and I want to minimize that cost, but I have no kind of interest in the mix. I'm not an operator of networks and I'm not a seller of heat pumps. I just want the most cost efficient solution. And in that sense, you're choosing between, if you assume zero carbon grid electricity, which we are going to have fairly soon, so we need to start assuming it. If you assume that, then you're choosing between two zero carbon options, assuming that the heat network is either electrically powered or from some other zero carbon source. There's a bunch of other parameters here that I'm not going to go into because there isn't time. But as I said, anybody is welcome to have a look at this themselves online. You also, if you're going to do network MPV, I'm sorry I'm going a bit quickly, but I'm worried about running out of time. If you are going to do network MPV, then you need to say what you're going to charge for the heat. And you can also kind of make it do a sort of simulated negotiation with each of the buildings. So if you tell it at building level what they're paying now, it will work out if it can undercut that and still improve the economics of the network. And then you also need to say what it costs to connect a building, and that might be one cost for buildings that already have a wet heating system, and another one for buildings that don't, where that would then need to be installed. Very, very importantly, you also need to state the pipe cost table. So these are the heat distribution pipes, and essentially bigger pipes cost more to buy and to install. And this is expressing that and how it varies depending on whether you're on hard or soft dig. So if you've produced mapping data where you know whether a road segment would be hard or soft dig, then you can flex the costs accordingly. There's also some additional dialogues to specify the flow and return temperatures in the heat medium and pumping costs. There's a little model of insulation. I'm not going to get into detail because there isn't time, but you basically can say what it costs and what effect it has. And then there's a model of, quite a simple model of alternative heating systems, which fundamentally say, what does this thing cost to buy and install, and how much is the heat cost that comes out of it? So you kind of bake your coefficient of performance assumptions into your estimate of the heat cost. So, you know, if you had a COP of 2 and you thought that electricity cost 16p a unit, then you might say that a unit of heat out of this machine would be 8 pence or 8 currency units. So that's the definition of a network problem. And then what I'm going to do is show you an answer. So on the next, so what we have here, here's a very similar question that I prepared earlier that I've already run. And you can see now that we have some pipes emanating from the supply location. And if we click on a pipe, we can see its capacity and diameter and so forth on the pane on the right. We can see that there's a bunch of buildings that have been colored in green and are not on the network. And those are the ones that it deemed it more economic to give their own heating system to. And the purple bits of road are pieces of road or buildings, if there were, that can't be reached or don't go anywhere. So that's sort of what I was getting at earlier when I said you need to kind of expand your road selection to make sure that buildings can be reached. Just trying to think what else to say about the map view. You can switch a legend on, which is nice, and you can hide or show the sort of mapping of the pipe sizes as line width on the screen. You can remember what your question was by switching between constraints, which kind of means problem definition, and solution, which is the answer. So how am I doing for time? Not too bad. I guess the other thing you can do is, I'll just show you a couple of the tools. You can, you might say that actually you know that there is a route that isn't in the map, and you can in fact add routes. So I could sort of connect, I don't know, I could connect this building to this piece of road by just drawing a new segment on the map. And I could also delete that. And the other thing is quite usefully, I could say, oh, actually, I know that there's a really good heat supply here. And then I could sort of edit. I mean, this could be a demand or a supply. So I could state its demand, etc., using this dialog. And I would be wise to connect that to the road network. Otherwise, it won't be reachable in a problem. So now I've kind of added either a supply or demand. They're always circles. So you can tell that it's one that you made, not coming out of the map, because there aren't that many round buildings. What else? Yeah, I guess there's some nice tools for selection management. So if we go back to constraint view, I can sort of select a bunch of things, and I can sort of whittle that selection down over here. So I can go, oh, I just want to see all the residential buildings. I could just click on the word residential, and that would filter the selection to just those buildings. And in fact, I think that's actually a road attribute. So that was the wrong way to use that. What you need to do is, first of all, whittle it to buildings, and then whittle it to, there you go, houses. And it's that's kind of filtered out the houses. Then you could go, I don't want any houses in my network, by filtering them out. Or you could say, I must have all the houses in my network. So yeah, that's a really quick tour of what it's like to make a map and set up a problem and get a solution. The other thing it does is, and this is based on some work by Marco at Imperial College, and I should say that the network model, Imperial were very helpful in helping us develop the underlying optimization model here. And then also there's a supply model. So essentially, for a supply problem, you would first have already created a network. So you've got a network, and this kind of mirrors the way it's done by network designers in the real world. It's the question of what network should I make and what supply plant mix should I have is too big to answer in one step. So you first make a guess about the cost of supply. You then solve the network for that assumed cost. And then the next thing you want to do is do a much more detailed kind of hourly model. And then there you need to have stated some demand profiles and some price time series. And these profiles here, so you see residential, commercial, flat, these are all things that we can assign to buildings in the map. So if I were to edit this building, I could assign, a flat demand profile to it, and the effect of that would be that its demand peak would not be diversified, so it would just be added on to the set of other demands whose peak it needed to be combined with, which is an essential part of the network modeling. So going back to the profiles, you set all this up, you specify what technologies are allowed to be used at the supply plant. So here we've got a little model where we're saying it's allowed to use a gas boiler or a CHP or a heat pump. It can have thermal storage, and there's also the possibility to sort of state that there's a substation with a constrained headroom or a constrained export capacity. And then the point of that is that when that's exceeded, that will be a hard limit on the use of electrically fired technology or electricity export. So you set that up. There's a few little things you can say about the objective. So what's your accounting time period and what's your discount rate? Is there a cost for curtailment? Are you allowed to sort of have power-led CHP or not? And some emissions and some computing resources things, which basically allow you to limit the runtime by compromising on the quality of the answer. And then you get another solution, which is basically what mix of technologies has the model selected so as to minimize the cost of meeting the demand experienced at the supply plant, which is sort of like the diversified sum of all the demands in the network. So this gets nice and detailed, and you can see that sort of on a peak day, it has to use gas boilers here. That's the only time it's using them. It's topping them up with storage at the peak, and the heat pump's kind of running flat out in that period also. And then if you've chosen technologies that export power, then it's going to give you a kind of fuel input output picture in terms of power generation on your plant. So that's the sort of functionality. The other thing that's really nice about this is that you can download, for one, you can download a spreadsheet that contains all the parameters that you entered. I'm not going to do that now because I'm sharing the browser window, and I'll be courting disaster if I try and change which window I'm sharing during presentation. But essentially, this gives you just a Microsoft Excel spreadsheet, which is a record of all the assumptions you made. And we are planning to add a feature so that you can send that back in. So you'll be able to edit your assumptions offline and then use the same assumptions for a bunch of different projects without having to sort of re-enter everything by hand. And then the other thing is that you can download the spatial data with all the demands on it and stuff, currently in the form of a GeoJSON file. We'll probably add GeoPackage to that. And yeah, I suppose a good note to finish on would be that there's a fairly extensive help page, which is you don't need to make an account or log in to see this. You can just go to this URL, which is tool.thermosproject.eu/help. And this goes into quite a lot of detail in terms of giving an overview, showing you how to use the program, and then like quite a lot of detail on how the heat demand estimates are done and how the network optimization model works. And yeah, so I think we'll leave it there with 2 minutes to spare. And I think that I'd be happy to take any questions you might have about that at 11:25. I think we've got a Q&A session. And for now, I think that the next person to speak will be James from Islington Council, who I'd like to hand over to, unless I've got the schedule wrong. No, I haven't. Good. You're muted, James.
Hi everyone. Yes, I'm James Wilson. I'm the Energy Sustainability and Consultancy Manager at Singleton Council, and I'm just going to give you local authority perspective or end user perspective on THERMOS. So next slide, please. So in terms of district heating's role in net zero, I mean, I think most people in my position across local authorities in the UK at the moment will be focusing on net zero, putting together action plans after climate emergency declarations. And I think it's fair to say that district heating is going to be a key part of delivering this, especially in urban areas. You know, the Committee on Climate Change estimated that I think 1.5 million homes would be connected to district heating by 2030 and 5 million by 2050 in their main scenarios. I think half of all non-domestic heat would be, nearly half of all non-domestic heat would be coming from heat networks by 2050. We've recently published our net zero strategy, and district heating's got a high profile role in that. You can see the front cover there features our new district heating energy centre, the one that takes heat from the London Underground tunnels. And the net zero strategy has several commitments in it that involved expanding or looking at building district heating networks that you can see listed there. So for example, completing engineering design on the Green Skies project. So Green Skies is a project where we're looking at building an ambient heat network, again using waste heat sources, looking at new waste heat sources and feasibilities, and connecting new buildings to our existing heat networks. In London, we've also got the Draft London Plan, which hopefully will be published soon, and that states that major developments in heat network priority areas have to have communal low temperature heat systems, and there's a heat hierarchy which has district heating at the top. The whole of Islington is in a heat network priority area, so this will be applicable to all new developments in the borough. Next slide, please. So in terms of where does THERMOS fit in? So I think from our perspective, there are three kind of main stages of district heating planning. There's the master planning. So it's basically working out, you know, where's the best place to build heat networks. So looking at heat demand and potential sources. Then there's the early feasibility stages. So it's identifying, you know, suitable potential connections, looking at the pipework routes, looking at potential energy centre locations, and then going into the detailed feasibility, which then ends with the business case that you present to get sign off for the project. I mean, I think THERMOS really covers all three in many ways. So at the master planning level, you know, it shows heat demand data across an area, and you can pick out from that where's the best place to build it. And then the early feasibility stage, you know, as Josh showed, there's building level data for the data, so you can identify, you know, which buildings you want connected, the roads, the appropriate routes, and also looking at where's the best place to put energy centres, because the tool can let you choose. If you nominate multiple potential energy centre locations, it will choose the best one for you. And then also now it's got quite a lot of detail in it. It's pretty useful in the early stages of the full feasibility. So I think, you know, it can cover all three, but I think where we really see it, and if you want to click again, it's the early feasibility. This is the main bit that I think it will cover. Next slide, please. So in terms of how this what the benefit is of THERMOS for local authorities, I think, you know, the main benefits are it's a simple interface that can be used in-house. So rather than getting in consultants from day one, I think quite a lot of the preparation now can be done by officers using this tool, which is really useful. It provides, you know, good estimates for buildings. Don't know how many people on the call have been involved in trying to do heat network feasibilities, but it can be extremely difficult sometimes to get data on heat demand for buildings, especially non-public sector ones. And I think that THERMOS provides a really useful estimate of these buildings that can help you assess whether a building is suitable for connection if you don't have the actual data. It's got limitless scenarios, and you know, this has been covered earlier in presentation, but I think this is the real benefit of it, currently, if you do a feasibility study and you employ a consultant to do it, you can only give them, a quite limited set of options to assess. Otherwise, the cost of doing the study increases quite quickly. THERMOS means that you can do almost limitless scenarios and get the results out of it really quickly. As a local authority who have done more, I think at one stage we possibly got the most funding from HNDU for feasibility studies. This kind of thing proved really helpful. And the model also identifies, the best buildings to connect as well when you do when you run it. Next slide, please. And so far, we've mostly talked about new networks, but the one good thing about THERMOS, you can also use it for modeling existing networks. So this, the two diagrams on the right, that's the existing Bun Hill heat network, which is owned by the council. So at the moment, we're looking at expanding that, and we've got a few options, both to the south and to the west of the network, which is new council estates. We're looking at connection. We've also identified a potential new energy centre location, which is adjacent to a data centre, which would be a heat pump that supplies cooling to the data centre and heat to the network. And so we're kind of wondering now which are the best new buildings to connect, and do we need that new energy centre yet? So we run it through THERMOS, and it basically comes up with the correct answer that the new energy centre is not quite needed yet. And also it picks out the two best connections for us, which you can see the results in the lower diagram. You can, as well as using it to assess new connections and supply options, you can also use it to identify the impacts of changes in supply costs. So for example, if you're replacing a gas boiler or CHP with a heat pump, or there's expected changes in utility costs or tariff changes as well. If you want to look at the impact of offering lower or higher tariffs, what that does to a network's finances. So yeah, I mean, when THERMOS came along, we were really excited to be involved in this project due to the amount of feasibility studies we've been doing for district heat network. And I think it's fair to say that we're really happy with the end result. Well, nearly end result, because it's not quite finished yet, but no, it's looking very good. So that's it from me. Thank you very much.
Thanks very much, James. Now I'd like to introduce Valdis Reekstens, if I'm pronouncing that right, and I'm probably not, and I apologise, Valdis, because I should have learned it by now. We've been working together for nearly 5 years. I'm speaking as someone whose name is never pronounced correctly. I know it's really annoying.
No.
So, yeah, going to hand over to Valdis, who's been using the THERMOS tool in the Latvian town of Jelgava.
Yes, hello. Yes, so I'm representing Fortum. It's district heating company which delivers heat for all Jelgava city. And I will tell about why we joined this THERMOS project and why we are happy that we joined this project, because now it helps us in our daily life when we are planning to expand our existing district heating network. So next slide, you will see basic technical data about how we are delivering heat to Jelgava city. The main source of heat is one of most modern bio-CHP plants in our country. So it gives about 45 megawatts of heat maximum load, and also produces electricity about 23 megawatts. And we deliver heat of most multi-apartment houses in the city. It's about 16,000 households, about almost 200 business customers, and on average we sell about 175 gigawatt hours of heat. Our network is 75 kilometers, and we are now looking how to make it more longer and more efficient. In the next slide, you see the main services which we offer to city. It's everything related with delivery of heat. We are not only producing and delivering heat, but also organizing reading of meters, and dividing for each flat the heat consumption. It's not typical in our country, but by historical reasons, we have this duty to do all the invoicing in flat level, not per building level. And also we do service of heat substations for most of our customers. Okay, next slide. You can see, yes, what are the focuses we are working. One is technical improvements. We just last year, yes, thank you. Just last year, we finished heat storage. So it was a very successful project. It gives better results as expected. We are now working to change our fuel. At the moment, we are mostly using wood chips, but we have started project to add also RDF, this from energy, from waste to energy fuel, also add in fuel mix. And those are very practical and technical and easy to calculate projects, but the hardest part is network efficiency and density, which we are struggling already for longer time. In next slide, you can see what are the main limiting things that makes us struggle to planning this development of network. And one thing, we are quite small company compared to our big cities in country, and we don't have internal resources to do technical, complicated calculations of investments and sizes, and then all those design work. And when we really need that, before that we were using outsourced companies, consultants, which were quite expensive, and it was quite long time to get some results. Some cities in Latvia, they use expensive and complicated software, but their network is 10 times bigger than ours, and they have daily tasks, and someone is specializing on that. The software is expensive, and also workers have to be trained to work with that. So far, we are mostly just focusing on very specific cases, one object cases where someone wants to connect to network, or we want to connect it. And it then our engineer was spending time on that, and mostly it wasn't his first priority. So in next slide, we can see that the main question is, if we want to expand our network, where to focus, where it would be more reasonable and feasible. In next slide, you can see our existing network, and with one click you can see that there is a lot of places we could go and expand our network. And it's always have been discussions which are the areas are most interesting, but never any of our specialists had time to really do some even draft calculations about what is the demand, what are estimated investments to connect some kind of area and city, and which part would be more interesting even from investment and demand perspective. And the next slide. Yes, so THERMOS is like answer for those problems, because it allows us very fastly and actually almost without any costs to do those first feasibility calculations. And there is actually not needed very technical and deep knowledge, because I'm and some of my colleagues are using, which are not engineers, and for basic calculations, it's enough easy to do those works. And next slide. Yes, this is a map view, but so the idea is that we have existing network, we take some area and city, how we use a tool, and then we just take some area and see what is the demand of, for example, private houses, and then we see it's feasible, And then we can like do the next calculation. What would be our mathematics if we just connect 3 buildings, and if we would connect some 5 buildings? So we, within 5 minutes, we can just do a recalculation and compare the results depending on, for example, if the customer say, I will never connect, and some house which is a little farther said I would like, so we can again recalculate in that new situation what would be estimated investments and demands for this small network expansion. And it's very good that the tool have been improved during this project, and there is a lot of features which really can are helpful. We can put this demand point anywhere we want, for example, like existing network corner, and then make this new network, small network, and we can make lines also manually if it's needed to make some areas which are not yet built. If there's something planning to be built, we can also add those. And to make it run, yes, next slide, we can see what data is needed. And like Josh mentioned, there is 2 options. You can use OpenStreetMaps or some GIS files from your city, but we were struggling with this GIS format, so we used OpenStreetMaps, and luckily we got LiDAR layer which was added on OpenStreetMaps, so we have more precise demand estimates, which takes into account also how high buildings are. Piping costs is also the tool have changed. It's very easy to add all the costs, and you can also include some kind of, you can include new piping cost if there's some specific area. For example, you have to cross some very difficult area with some, you have to cross, I don't know, river or tunnel, so you can add bigger cost for that specific area. So you can make quite precise calculations on the investment part. Then tariff in our case is very easy. We have one tariff for all city, and also you can use all those production costs and financial inputs about investments in heat supply part and emissions, but we don't use those functionalities because our main target using this tool is to expand network and understand which areas of city are most interesting and for everybody, for us and the customers. So we just use some part of functionality of this tool. Yes, the next slide. Yes, so we don't use the full reports, but the main beauty, what we like, that we have the main data what is needed for our decision-making process, that we can see what is the investments required, what is the demand, and that's actually the main thing which helps a lot. And we also helped some other cities to work with the tool, and they mentioned that they actually saved a lot of money and they could make decisions playing with the tool for, I don't know, 1-2 hours, and they can make decisions. Actually, should they ask some consultants or technical designers to do some very accurate calculations or not, so they can do this feasibility very fast and with high reliability output. And the next slide, the main conclusion is that it's very helpful with this very short time to get analyze specific network areas to expand it, and its qualities for us is enough good to make decisions about next steps. So I encourage you to try this tool, and we think it will help a lot of cities and utilities in their daily work. Thank you.
Thanks very much, Valdis. I think, well, we're running ahead of schedule, which is nice. And I think the next thing is probably questions. So I'm going to let Jess take over here, and then I will listen carefully. And if any questions come my way, I'll try to answer them.
Yeah, so if we work under the same principle as before, so if you want to ask a question, either if you show your video, and then that's a good highlight to me that you want to speak, and I'll ask you to unmute, or alternatively, if you're camera shy, feel free to put a question into the chat bar and I'll read it out on your behalf. So I think we've got everyone, all of the speakers bar Chris, I think, are available to answer your questions. So if you want to ask it to a specific person, maybe put their name at the beginning. So Josh, could you explain heat networks again? Hopefully that's not going to be a question. And yeah, I think Josh and Chris have been busy answering people's questions in the chat section. So I think the only one that was asked earlier that wasn't addressed was, I think Derek said, will you make the THERMOS tool available to current DHN suppliers?
So yeah, I think Martin alluded to this. So right now the tool's available for anyone to use for free because we're sort of still in development and we're wanting to sort of build interest and get feedback. And we're in the process now of figuring out what our sort of strategy will be to sort of maximize the impact of it and raise enough revenue to sort of maintain and keep developing and adding features. Because one of the things that happens is anytime anyone uses it, they think of another great idea for a feature that it doesn't have, and it'd be nice to be able to do those. So yeah, I guess the simple answer to your question is yeah, we want everybody to use it. The slightly more complicated answer is you can use it for free at the moment. I think there'll always be a free version, but there'll probably be some advantages to paying for it. Otherwise, you know, nobody will pay for it.
Great. And I think Vicky put a message in, but I think it's more just to say that Valdis's presentation was very interesting. And also I was wrong, Chris is still here, so you can direct questions at him if you'd like to. I don't think I'll pronounce your name right. Charmian asked, what is the range of heat load types possible, e.g. swimming pools, factories, greenhouses? One for Josh, I would think.
Okay, so I guess there's two answers to that. So the first answer is, what kind of demands is our demand model good at guessing? And it's only good at guessing space and water heating demands. So it's because it's essentially it's sort of machine learning model that's been trained to recognize the shapes of buildings and associate them with their space and water heat. So that's what that does. So anything where the heat demand's not correlated with the size and shape and is like not space and water heat, it won't do a good prediction. So industrial heat loads, high temperature heat loads, which might not be relevant in terms of being able to be met from a heat network anyway. Swimming pools and things like that. That's where it's really important to be able to overwrite the estimates with your own data. Basically, I think we've come up with a really, really good way of guessing the demand, but it's still inferior to a measured demand. And yeah, for those categories of load, you definitely can't rely on it. And the second part of that question is the network model doesn't care. So as long as you've got a number in there that's right and you've got the right peak and you've told it whether or not that peak should be diversified, then any demand can be connected. And again, just a caveat, you need to think about what the temperature requirements are for that demand. So it needs to be a demand that can be met with the temperature of network that you're modeling. So if you've got if you're modeling a 50-degree low temperature network and you've got a demand connected that needs 90 degrees, then you've obviously got a problem. So you need to think about the way you structure the question.
Perfect. And I think this is also for you, Josh, I would imagine. Can a heat and cooling network be optimized together, including either an ABO or heat pump capable of producing both heating and cooling? That's from Sven.
So the answer to that is no. We can do heat networks and we can do cooling networks, but we haven't built software that can think about them as one system. That's on the list of things that it's definitely like an interesting suggestion and it's worth exploring. It creates a challenge, which is just the way the optimization works is kind of constrained by the number of decisions the model has to make to solve a question. And if you put more buildings in, that makes more decisions. If you put more bits of road in, it makes more decisions. And right now the model can probably solve a sort of 5,000 building problem in maybe like half a day or a day. But if you then say, oh, well, I also want to combine all the decisions about a heat network with all the decisions about a cooling network, you've probably kind of exploded that in an exponential way. And now you can only do like 50 buildings, which might be too few to be useful. I'm only like speculating about the impact on scale, but I'm just saying there's a trade-off between the complexity of the question and the size of the question that you can answer and get, you know, an answer in your lifetime off of the computer.
And then Digby asks, does THERMOS sound the death knell for consultancy?
Yes, Digby, that was the whole point of it.
We hope we
No,
succeeded.
I think that it might make what I hope happens is it makes the conversation between consultants and their clients more transparent, and it leads to better informed clients and more, like, what it should mean is that for a given budget of days, you can do a much more comprehensive search of the problem space, if you like. So when you then get to the next bit, which THERMOS doesn't do, which is detailed engineering design and hydraulic modeling, you know that you're looking at the right thing and you're not putting all that labor intensive work into you know, a master plan level idea that isn't necessarily the optimal one. So I think the answer is no. I think hopefully what it will mean is more consultancy, but more effective consultancy.
Perfect. And Joseph asks, can thermal storage be designed in the district heating network? If so, what are the inputs and outputs for the storage design?
So storage can be represented, but only currently as part of the supply optimization. So the limit to that is that it has to be on the same site as the main plant, which is like often the way it's done, just because if you want the storage to, you know, just in terms of the pipe sizing economics, you probably want the storage and the main supply unit in the same place. But essentially, and then the inputs and outputs are, as I showed briefly, you need to, I can't remember them all now. Actually, I could look at it and tell you. I don't need to share my screen again. Let me do that. Just bear with me. We've got plenty of time, I think, haven't we?
Yep,
So
plenty of
yeah,
time.
yeah. Just sorry, just bear with me a sec. So yeah, the parameters for describing storage at the moment are lifetime, capacity in megawatt hours, capacity in megawatts, percentage efficiency, so that's like the round trip loss, and then some cost parameters like a fixed cost, a cost per capacity, and a cost in kilowatts, and a cost per capacity in kilowatt hours. So it's not a particularly complicated model. There's no physical model of the store.
Great. So Charlie up next, he asks, hi Josh, have you compared a THERMOS model output to an existing HN in Islington or Jelgava? If so, what was the error margin in the results?
So yeah, that's a really good question, and that sort of is a question about model validation. And I guess what I say to that is that we are still doing work on, we're going to be producing a paper as part of the outputs of the work, which sort of quantifies the answer to that question. It sort of needs to be quite rigorously done because you don't, there's two ways that the answer could differ. So one of them is just that your inputs aren't quite the same as the real network on the ground, or three ways. Another way is that the network itself wasn't designed optimally. So that's likely because nothing's designed optimally in this world. So you might have either different input assumptions than the designers had, or it wasn't an optimal design anyway. And lastly, you know, THERMOS could be getting it wrong, and we've got a design experiment to sort of rule out the first two so we can focus on the last one, because that's the bit that we need to get right. So what I'd say is it's pretty good. It looks, I mean, it looks really good, but I can't give you a number at the moment, but that will be part of the final outputs of the project. So, you know, in the spring. So I'm not trying to get off the hook there.
So the next question from Federico The heat demand and peak demand guessed by THERMOS are defined at building level, correct? If so, does THERMOS assume a synchronicity factor when sizing the pipes?
Yeah, so how this works is the network model only understands two kinds of time. So it understands annual demand and it understands peak demand. And then to account for the fact that, as you're alluding to, if you've got 10 buildings and they've all got a peak demand of 10 kilowatts, your group doesn't necessarily have a peak demand of 100 kilowatts because they might not all peak at the same time. And that effect is called load diversity. And what we do is we use a statistical method. So we basically use a standard network design rule as the number of buildings in the group goes up, so the peak demand is not the sum of the peaks, but the sum of the peaks multiplied by a factor that reduces it. And the reason we have to do it that way is that we've put all our sort of decision resource, if you want, into the network problem, because we felt like that was the really hard thing that hadn't been cracked, and we want it to be able to answer as big a problem as possible. So we couldn't put in, like, the only other way of attacking that is to put in an hourly or a half-hourly time series for each building. And if you do that, you've basically exploded the problem hugely, and now you can only do 5 buildings. So we had to make a trade-off. So we've used a kind of statistical method to represent that effect. You can, for a given building, you can say this one is on all the time, so its peak just gets added. But that's as far as that goes.
Next up, Charmian asks, it appears that background data is included in the model. What plans are there to keep this up to date?
Okay, so background data, the data that is not really in the model, we've written some software that talks to OpenStreetMap. So what happens is, like when I sort of showed you how you make a map at the beginning of my presentation, that's literally our program goes and talks to OpenStreetMap and says, please, can I have all your buildings and roads that are inside this box that my user just drew? Then that gets stored in a database on THERMOS, which is only accessible to you unless you've decided to share it. And that is in a database because that's the technology we're using to store the information that the application uses. But essentially that's a static copy. And if you want to, OpenStreetMap gets updated over time. And if you want to sort of see if any more buildings have been added, you go back to OpenStreetMap and make a new map. And then the latter one is sort of, answer to your question would just be, as long as we've got, we've guaranteed to keep the server running that we've got at the moment for the next 3 years after the project ends. After that, it's sort of a question of, what's the operating context and who's paying for it, and have we got the resources to, what service level agreement have we entered into, I suppose.
Charmian has added to that question that I was thinking of such things as pipe costs, etc.
Okay. So pipe costs, we are going to add some pages to the help documentation which give you some ideas of pipe costs that we found, but the pipe costs that you saw in the problem that I was demonstrating are numbers that I put in, and they're not available to anybody else. They're just in my problem. And that's important because sometimes people see pipe cost information as commercially sensitive, so you don't want everyone to be able to see everybody else's information. But it's also a very important parameter, so I think it'd be really helpful for us if we shared what we could.
Michelle asks, is it possible to include on-street data or potential pipe topology data? We often see that OSM data has topology problems. Yeah, absolutely. So OpenStreetMaps isn't as good as, whenever I'm using THERMOS for a client in the UK, I'm always using Ordnance Survey buildings and roads. And so the answer to your question is yes, if you know how to put together the map data that you want to use, you can use that instead. And in fact, what you can do is, so my workflow would be use my own processors to generate a representation of all the buildings and roads for the area that I want, upload them into THERMOS, tell THERMOS where I know the demands of some of them I don't want it to guess, and then just have it guess the ones I don't know, and put the LiDAR data in so that I get nice 3D building estimates. So yeah, fundamentally, you've got complete control if you're using your own GIS data. Joseph asks, what is the scalability of THERMOS? How many buildings can be designed with THERMOS? Is there a maximum limit? And how about the calculation time?
Okay, so that's a good question. I guess there's different kinds of scalability. So you're talking specifically, I think, about the scalability of the model and the size of problem it can solve. So I'm going to focus on that. I think, well, the answer is you never really know until you run a model, because like the technology that's actually coming up with the answer isn't software that we've written. Our program basically compiles, like, and this is based on the work that Kamal did earlier in the project. It compiles your question into a linear model. So it turns your whole question into a very weird long equation that doesn't look like anything like a network, and then sends it to this specially designed program that's really good at solving those equations, called a linear solver. So the number of decisions in that equation just make the equation longer and longer and longer, right? Because every decision is kind of like a binary variable in the equation. Is it a yes or a no for this thing? Is it a yes or a no for that thing? So the more buildings you put in, the worse that gets. And then also those models have the linear solvers have got many more person years of work in them than THERMOS, for example. And they've got a lot of really clever software that minimizes the number of problems that it has to actually analyze. So it sort of like rules out huge subsets of all the possible solutions by proving to itself that nothing in this region could be the answer. And so it's really good at minimizing its workload and solving that bit. Some kinds of question make it harder for those heuristic, well, they're not heuristics because they're deterministic, but make it harder for those tricks to work. So if you ask a question where the answer is really marginal, it will take a lot longer than if you ask a question where the answer is clear cut. That can be instantaneous, and it's hard to tell what. So that's one thing, is it kind of depends on the question. Secondly, it also very much depends on the number of buildings. And what I'm finding is I can do a 5,000 building problem in sort of like 10 to 20 hours. And I mean, that might sound like a long time, but there's no human alive that can do a 5,000 building problem and get an optimal answer, like, ever. So it's sort of, yeah, it's coming at the problem in a completely new way. So it's hard to know like how long you should have to wait, I suppose. But the answer to your question is 5,000 buildings are going to take 10 to 20 hours. We are introducing some features that might make it possible to do bigger problems. So if you don't mind, changing the decision making to be, instead of each building, it might be all the buildings in a postcode are either on the network or not, or it might be all the buildings on a block, on a street block, are either in or not. You can kind of shrink the number of decisions, and then you've kind of answered a slightly different question, which means you might not get the actual optimal answer. Like if the right answer is I should connect half the buildings on the street but not the other half, but if you've aggregated the problem, then the optimizer can either only do all of them or none of them, and neither of those was like the right answer. But it might not matter, because sometimes the optimizer is choosing on really fine margins. Like literally, if it saves 1p over 40 years, it'll be like, oh, I'm not doing that. So there's a kind of question about how a human designer would approach it as well.
Erica asks, you mentioned you were working also with cooling networks. Is the building demand estimated in the same way? Are you taking in consideration also dehumidification?
So it does do cooling networks. The cooling demand is estimated in a completely different and much more simplistic way, just because we couldn't get any cooling data to train a more sophisticated model with. So the way the cooling model works is just floor area benchmark, and then some European spatial data on the typical cooling need per unit floor area in different sort of climate regions of Europe. And so what that basically is sort of saying is, if this building were to be cooled to the sort of expected level for that building in that location, then this would be its cooling demand, and then the network sees that demand and tries to satisfy it. And we're not taking into account dehumidification. I'd be interested to hear what you think is the right thing to do with that. You can type it if you want. Or send me an email another day. Didn't mean to put you on the spot.
It looks like we may have reached the end of the questions. There's no more in the chat box, and no one has their camera on. far as I can see. Oh, Charmian says this is looking at the long term.
I think they're not finished typing yet. There's no little dots to tell you if someone's typing it. So.
We have to fill the space.
Okay. Does it include climate change? I mean, I suppose what you could do there is go like build a map with 2000 heating degree days, and then build the same map with 1500 heating degree days if you think it's going to get warmer. And if you think that the Atlantic conveyor is going to fail and it's going to get significantly colder, then you can put 3000 heating degree days in, and then basically go. Then you've kind of got a kind of what if tool about climate scenarios. So you could do that.
And Federico says, can insulation class of pipes be defined as input, or THERMOS uses a default inbuilt value?
That might be one I'm not sure of the answer to. So there's a heat loss model. So you can certainly define whatever cost you want per whatever list of diameters you want the model to be allowed to use. And you can vary that cost by some parameters that you choose, which could relate, for example, to hard dig, soft dig. I can't remember what the heat loss model looks like, so I don't know. I can look at it while we see if there are any other questions and see if that jogs my memory. But I would also say have a look at the help pages on the heat loss model, because it's actually documented there. Yeah, I think it's not exposed to the user at the moment, the heat loss. You can define the ground temperature, right, and the flow and return, but the losses, I think, are kind of fixed based on the ground temperature. So we don't have the ability to say, oh, but this is a series 2 pipe or a series 3 pipe. Might be a good feature to add.
I don't think there are any more questions by the looks of it. So unless someone comes up with one anytime soon, I think you've already had 20 minutes of questions, Josh, so we can maybe let you off the hook. And I think Martin is due to do a little summary at the end.
Yes, so yeah, we good to finish earlier, I guess, in some ways. Yeah, we just allowed more time in case the presentations went on a bit longer and there were more questions. But yeah, thanks for all your input. Thanks for joining, and please do try the tool when you can. As it said there, we'll be sharing the slides in due course, but please do get in touch with us if you have any further questions. So yeah, and check out the THERMOS website. As I said, there's 4 more months of the project, so there's updates on that as to what's happening. Yes, so thanks very much, and yeah, I think we can draw that to a close. Any final words, Josh?
Just thanks everyone for coming and showing an interest, and yeah, look forward to hopefully interacting with some of you when you're using it, and some good ideas there for future development. So it's always nice to keep a list of those. And obviously we're sort of open to talking to people about different ways of making that happen. Thanks everyone. Bye.